Okay, so this video is first of two in this module on loops, and what we're going to be looking at is how we make the computer execute the same exact or the same instruction in Python over and over and over again, which provides a tremendous amount of convenience. And when coupled with the branching that we saw in the last module, gives us what's called a Turing complete machine. And if you read along with the book, you heard of Alan Turing, and he developed a computational model that sort of outlined what was possible to write in a programming language and what is possible to do with a computer. And loops are one of the last big steps to really being able to develop very general purpose programming. So before we dive into this just yet, though, sort of want to I closed the last module with a warning about how things are going to start to get a little bit more difficult if you're new to programming, and I want to open this one up with the same warning. Around the time of branching and looping is when someone who, if you haven't programmed before, things can start to feel a little bit overwhelming. Programming is not a fact-based discipline. It's not something that you can just sort of read the book and you know the answers. It's an engineering discipline. It's much more analogous to learning calculus. You have to do it. You have to program. You have to practice a lot to get good at this, and it takes a lot. It takes a while to really be able to think like a programmer and think in terms of a logical sequence of steps. So, you know, if this is your first time programming, I've been going fairly slow so far. I'm going to start to speed up now. And we're going to start to see a lot more material coming at you. And it's important that you're doing everything that you can to stay on top of things. So reading the textbooks, doing all the programming assignments is absolutely pivotal. On the flip side, if you're taking this course and you've already learned how to program in C++ or Java or some other language, and you're just taking this course to kind of learn Python, you're going to find that, well, you may have already found that the first few modules are sort of slow. They're aimed at beginner programmers. We are going to start to move a little bit faster now. In the next few modules, we'll spend introducing still some very primitive parts of the language, but as we start to move through data structures and lists and dictionary objects and into classes, you'll find that you're going to start implementing and creating a lot more sophisticated and larger programs. So if you're already an experienced programmer, hang with us for a little bit longer. If you're new to programming, hang on tight because we're about to get a little bit um, more involved. Okay, so loops. Let's think about why we want loops and why we should use them. What if I wanted to print out the numbers 0 through 9 to the screen, one on each line? So uh, this is something that we could do since the first couple of modules. I could just say print 0 um, and paste, right? Copy and paste. I can just do 1, 2, 3, 4, 5, 6. Paste a few more, 7, 8, 9. And my program, if I run it, Python 3 loops, it works. Okay, so great. Now you should be thinking, boy, that seems little inefficient. There's a lot of copying and pasting. It sort of seems kind of repetitious, right? We talked about dry, right? Do not repeat yourself. Seems like I'm repeating myself, all but exactly what I'm printing, right? My statement is fairly the same every single time. Now, if somebody asks you, how about the numbers 0 through 999? I think clearly right away you realize that the strategy that we took over here doesn't really work, right? As a programmer, we can't possibly then now um, copy and paste this thing 1,000 times. That just seems like a tremendous waste of effort. And in reality, oftentimes computers do the same thing or a very similar thing for hours and hours on end, right? Lots of programs run for a really long time. and they are virtually doing the same thing endlessly. And a programmer can't possibly type it. If the program's running for hours, you're talking about trillions upon trillions upon trillions of instructions, and certainly we haven't written trillions upon trillions of instructions, right? So we're missing a part of the language. All right, and of course that's loops. So before I get into a loop, I want to sort of show you how the premise is developed. These statements are all almost the same, but they're not exactly the same. The thing that gets printed is different every single time. So one of the key insights to this is that we can actually transform this by writing a little bit more code. We can transform this into the print statements actually being exactly the same thing. And what allows us to do that is use of variables, right? Variables can take on changing or varying values. So I'm going to start by creating a variable called x and setting it equal to 0. And each time I print, instead of printing out an actual value, I'm going to print out x. Now, of course, if I ran this program, I still get x printed out 10 times. It's going to be 0 every single time because x starts at 0 and it never changes. But what I could do is I could say x equals 1, x equals 2, x equals 3, right? And so on, right? So before I print it out, and it'll stay at 3 because I didn't bother to write them all here. But you can see it's 1, 2, 3, right? And so I can change x. Now I haven't really solved my problem though, because now this is fundamentally different than this, right? These two statements are almost alike, but just a little bit different. So I'm going to take it a step further. I'm going to say x is equal to x plus 1. Okay. So now, if x is 0, now x will be set to 1. 0 plus 1. That statement can be copied and pasted. I got a lot more code now, right? But in fact, let me group these a little bit differently. Let me think about it as printing and then changing x. The grouping really doesn't make a difference from the way the program will execute, but I think it'll look a little more familiar when we change this into a loop. So if I take that code and I run it, I'm going to get the values 0 through 9. Now, I'm not advocating now copying and pasting that 1,000 times, although that would be a lot easier, right? I could probably just hit copy and paste 1,000 times. Maybe it'd take me an hour, but I wouldn't have to edit anything. That's pretty good. But thankfully, what we've ended up with is the ability to write this sequence of statements. And notice that these two statements are exactly the same. They are repeated verbatim. Once we have it in that statement, in that format, now we can start to take advantage of a loop. So if I look at this, I want to keep pasting this until x becomes 10, because I wanted to stop when x became 10 or stop at x equals 9. So what I can do instead is just say while x is less than 10 and print it and increment it. I'm going to go ahead and delete all this and let's run this program now. And notice I get 0 through 9 again. The way this is working is that x starts at 0, and the while loop is actually, it looks, if you did it like this, right, an if clause from the last module, sort of understand that syntax already. Well, a while loop is very similar to an if clause. If this Boolean expression is false, or is true, I'm sorry, we'll execute this stuff. If it's not, if it's false, then we'll just drop down here. The difference with a while loop as opposed to an if statement is that once we reach this last statement, we go right back up to the top of the while loop and reevaluate the Boolean expression. And of course, because x is changing, eventually x will print out 9. Right, so if we look at our terminal screen here, we printed out 9. Then we did x equals x plus 1, meaning x is now equal to 10. We went back up to the top and we said while x, which is 10, is less than 10, keep going. Well, that statement is false. Once x is 10, it's no longer less than 10, right? And we're done, and we'll print out our done message. All right, and now with that message there, we can see it at the end. Thankfully now, the job of printing out the first 1,000 numbers is trivial for us to write. Certainly it scrolls across our screen pretty quickly, but we can print out any number of values pretty much effortlessly. Okay, so let's summarize that syntax a little here. So the anatomy of a while loop. Typically a while loop will always involve a variable, right? And a variable that is changing. And it might be while I is equal to 10, while I is not equal to 10. It could be while I is equal to j. It could be anything. Any Boolean expression is valid here. But generally, we're going to start by doing some sort of initialization. And typically, that's going to be maybe a user input. Maybe it's just going to be set to 0 like this. But the initialization is probably going to go before, or you're probably going to have an initialization before the loop starts. If you forget, in this case, like if I forgot to say I equals 0, I'd get an error because the first time I tried to compare I with 10, Python would tell me that I don't know what I is, right? So there is some sort of initialization required in that case. If it was initialized to 10, if I was initialized to 10 instead of 0, there's nothing wrong with that statement at all. But while I less than 10, that would resolve to false immediately and would basically just never execute anything inside the while loop. While loops don't have to execute at all, right? If you initialize the variable in such a way that the while loop is false right off the bat, then nothing will happen. Likewise, if I go back over here and I set x to be 9,990, if I run this program, it doesn't start at 0, it just starts at 9,990 and it prints until it's done. The Boolean expression gets evaluated each time we go around this loop. All right, so if the Boolean expression is true, we'll execute the code associated with the while loop, the indented code, and at the end, we'll go right back up to the top and we'll recheck it again. All right? If it becomes false, or when it becomes false, we'll stop. Okay, that's just explaining the same thing. Notice that we've got I equals I plus 1. Now that we're starting to increment and change variables very frequently, there is a little bit of a shortcut to that. So if we think about like x equals x plus 5, you notice that x is repeated at the same both sides of the assignment operator. We're setting x relative to its existing value. So remember that principle dry, don't repeat yourself. Well, it's a little bit more convenient and safer because we have less room for typos. The less code we type, the less errors we make. We can just write x plus equals 5. So you saw me writing I equals I plus 1. I'll start to now write I plus equals 1. Right? This is the most common, but you can also do it with multiplication, division, subtraction as well. So these are called combined operators, combined assignment operators, and they're very useful. If you've looked at C++, C, Java, C#, JavaScript, pretty much any language, you might be wondering about the plus plus or the minus minus operator. Turns out that's not available in Python. So if Python's the only language you know, then forget about plus plus and minus minus. You can pretend you've never heard of them. If you've seen another language, unfortunately they're not there. And what you'll find is that in Python you end up not doing that quite as much because the for loops, which you'll see later on, are arranged a little bit differently. But you know, everybody who's come from another language to Python, I think sort of have muscle memory for plus plus and minus minus. You have to break that a little bit when you're dealing with Python code. Okay, so let's do a few more examples. The syntax is pretty straightforward with while loops, but what you'll find is that there's a great deal of flexibility in what you can do with them. So practicing doing a lot of problems is probably the best way to learn this beyond just remembering the syntax. So first example, let the user enter an integer between 1 and 100. And I'm going to print out every even number up to and including the number that they enter. Right, so let's move over here. Okay, so first off, I'm going to have to get a value from the user. So let's say, x equals input. Please enter an integer between 1 and 100. And I'm not going to worry about the even part of it right now. What I'm just going to worry about is, printing out every number. Right, so let's scratch the even part for a second. Print out every number up to and including the number that is entered. So we'll start at 0. I'm going to create another variable, I equals 0. And I'm going to say while I is less than or equal to x, print I plus equals 1. Okay. So notice that this is very similar to the initial while loop that we saw when we had like something like a 10 here or 1,000 here. But now the limit of this loop is coming from the user. And it doesn't really make a difference where that limit came from. It's still the same structure and the same syntax. Now I'm going to print out every number from 0 through and up to and including x. All right, we're going to make sure that that comes out right. And then we'll worry about the even part. So I'll type in 13. Whoops. Looks like I messed up here. I got I got caught by the Python 2, Python 3 situation, right? So input returns a string, remember, not an int. Because it's a string, when I start to compare it with another integer, I got an error, right? So let's convert that to an int. Run it again. Okay, so now I see every number being printed out from 0 all the way to 13. All right, so I only want even numbers to print out. Well, how do I do that? Well, first off, one obvious solution would be, well, do plus equals 2 instead of plus equals 1, right? So if I did plus equals 2, I would start at 0, and it would keep incrementing by 2 instead of 1. Eventually, I would become 14, and that won't be less than or equal to 13, and I'd stop. Okay, so that works pretty well. And I think that's actually probably the best solution. I'm printing out every even number up to and including the value that I typed in. If I type in an even number, I'll see the value. If I type in an odd number, I won't really quite get to the number. Alternatively, I could also actually determine before I print it if I is even. And I can use the modulus operator for that. If you divide I by 2, integer division, and the remainder is nothing, means it divides evenly into 2 divides evenly into I, then it must be an even number. All right, now I've changed this to I plus equals 1. And if I run that now, you can see I get the same exact results. Okay. There is a key difference between these two loops. Right, so if I run that code now, I just added a nice little print statement so we can kind of get a picture of what's going on in our code. If you count how many times looping prints out, it actually gets printed out 10 times. And you can see that sometimes it's printed out twice in a row. Right? The first time it goes around, it prints out 1, then into 0, and then I becomes 1, and we print out looping, but we don't print out I. We go back around, and we print out looping again, and then we print out 2. Right, so this loop is actually going around 10 times, but on only half of them, when it's even, it prints. That's fundamentally different than having a loop that increments its counter by 2 each time. And in this case, I type in my same input. In this case, only actually goes around 5 times. Right? In computing, this would be considered a more efficient approach, but I get the same exact output. And that's something that a lot of people have trouble really understanding and kind of accepting, the fact that there's a variety of different ways to write programs that will have the same exact output, and sometimes they're objectively better ways to write it. So for instance, this way where we iterate through this loop 5 times instead of 10 times creates less work for the computer. It's objectively better. But there's other times where it's much more subjective. Don't think that your code's going to look like mine. Don't think your code's going to look like someone else in the classes. It's going to look different. It's much more like writing an essay than solving a science problem or science and engineering problem. All right, so let's look at yet another example. All right, so that was just kind of a simple counting example. Why don't we try to manipulate the user input a little bit more, or you take advantage of user input a little bit more. So for this example, we're going to do multiplication sort of the harder way, right? So we know 3 times 4 is 12. We know our multiplication tables, but multiplication is really nothing more than addition a bunch of times, right? A bunch of times in a row. So 3 times 4 is actually kind of more mathematically defined as 3 plus 3 plus 3 plus 3, 4 times. You see 3 4 times. So let's, for whatever reason, believe that we don't have a multiplication operator in Python. We could use a loop now to actually do multiplication using addition. Right? So what I'm going to have is a user type in both of these numbers, and I'm going to loop based on what they typed in. All right, so we'll call it A. So I'm going to remember this time to use my my casting, so I can convert that string that the user is going to type into an integer. Please enter first number. And I'll get the second number. And now I've got to actually do the multiplication. If I look at the problem statement, right? So 3 times 4 should end up with seeing 3 4 times, right, in the arithmetic. So what I'm going to do is I'm going to first write my loop so I can see the numbers print out the right number of times. Before I'm going to even worry about the arithmetic, I'm going to write a program that prints out the first number the user types in, the second number of times. So 3 4 times. If the user types in 4 and 2, you should see 4 appear twice, 2 times. All right, so I'm going to kind of go through this in small steps. So I'm going to create my counter, I equals 0. I'm going to say I want to do something b number of times. That's the second number that the user types in. So while I is less than b. Now why less than b? Well, I is starting at 0. Right? So if b is 3, I want I to be 0, 1, 2. Right? Three values. What do I want to print? Well, I don't want to print out I. I want to print out a. So let's see. 3 4. Whoops. I got a loop kind of indefinitely going. Right? And so this is one of your first examples of what's called an infinite loop. All right, so an infinite loop is any situation where you enter into a while loop and you never do anything to actually cause that while loop to become false. Right? So if we look carefully, well, first of all, what are we seeing here? We're seeing 3 print out indefinitely, right? Infinitely. This will continue and continue going forward. And the problem here is that I is 0, right? And I'm checking to see whether I is less than b. Well, b was 4, and I print a. And if that's all I do, I never changes. There's no implicit increment of I when you go around a while loop. You have to do it, and we've done that in the past, and I just forgot it here. All right, and so you need to recognize this, and the way to stop this is just Control C. You'll stop your program. That'll terminate it. You have to make sure that while you're inside the while loop, you do something that's going to get it closer to stopping. In this case, just I plus equals 1. Okay, so now we see the 3 times, the 3 print out 4 times. I want to kind of point out that the value of starting with just printing out some values, even though that's not really the objective of the program, it's to get our loop right. Right? It's very easy to see that you've got an infinite loop when you're printing out values. If I wasn't printing anything, if I was just trying to do the math that I'm going to do in a couple of seconds, my program just would have hung and it wouldn't have printed out anything at all, and it would have been very confusing as to what went wrong. Right? So starting by aiming to print what you're going to use will save you a lot of debugging time. Okay, so I don't want to print 3 4 times. What I really want to do is add it 4 times. So I'm going to create a sum variable and initialize it to 0. And each turn around the loop, instead of printing A, I'm going to say sum plus equals A. So the first time around the loop, sum is equal to 0, and I'll get sum equals 0 plus 3. The second time around the loop, now that sum is 3, it'll be 3 plus the 3. And then sum will be 6. And then the third time around the loop, sum will be 9, and then 12. Now I didn't print anything out, so I can see my loop terminated, but I didn't actually print the value out. Let's go and do that. And I get 12. All right, so again, I mentioned the infinite loop scenario. Let me show you what that's going to look like. If I got rid of this I plus equals 2, maybe I pretend I forgot to do it again. I mentioned that you would have seen your program just hang, and this is what I mean. Right, so I have the same problem as I had before. It's an infinite loop. It's really not as obvious, right? It's not nearly as obvious that there's an infinite loop happening because my program's just kind of blinking, sitting there, doing nothing. So again, printing to get those values out gives you a lot more confidence going forward. You can still do Control C, and now let's add it back. Okay, and we can do pretty much anything and get a value to it. We can also check if sum is not equal to A times B. And of course, Python does have multiplication, so we can do that. We can print out that there's a problem. Otherwise, print the sum. All right, this is kind of handy to make sure that, I don't know whether 90 times 13 is actually equal to that value, but now I let my program essentially check it for me. Right? And if I had messed something up in this code, maybe if I had kind of inadvertently set sum to A or something like that, I'd be able to see it. Right? There's a problem. Right? And I can print out the value that I got. This is kind of the first example of where we're really writing a little bit of code to check our work. Right? And I'll have a lot more to say about that as the semester continues. Okay, so just a little bit more with our loops, right? So loops are a very fundamental part of the language. It's going to be involved in pretty much any program that you ever write, and you should start to try to get a feel for how things are going to work. So let's just take some time and try to think about what this output will be. So starting on the left, the top left, this x equals 3. And I copied that over to the Sketchpad here so I can go through it. So we've got x equals 3, and we've got while x is less than 5, we're going to print the value. All right, and so to predict the output here, it's a pretty straightforward process. We want to start to have a mapping. Whoops, sorry about that. We want to start to have a mapping of what the variable values are over time. Right? So we've got this object called x. It's starting at 3. While x is less than 5, we're going to print it out and we're going to increment it each time. Right? So first time around the loop, of course, 3 is less than 5, so we print it out. Right? So we'll get a 3. We'll print it out, and then we'll change it. We'll update it to be 4. All right? The plus equals is that process. Now it's still less than 5, so we get a 4 on the next line. We update it, and it's 5. Right? So the variable x is actually equal to 5 at this point. We go back around the loop, and now this statement becomes false, and we don't continue. So you won't actually see 5 print out, but nevertheless, if I was to deal with it outside of this loop, like if I was to have a print statement after that loop, I would see that x is indeed actually equal to 5. But the output of that loop is just this. All right, so let's move on to the next one. We'll change color over here. Let's look at x equals 6. All right, so we've got our variable x. It's equal to 6, and this is a pretty simple one, right? So while x is less than 6, do the following stuff. Well, x is 6 right now. 6 is not less than 6. All right, my while loop won't run at all. So no print. Let's look it over here, and we'll change our color, I guess. So we've got X, we've got Y. X is 2, Y is 2. While X, 2, is less than 5, we're going to continue. We'll print out X, right? So we'll print out 2. And we're going to increment Y. Right? Y plus equals 1. All right, so now we go back around the loop and we check, and X is less than 5. Well, certainly it is because it's still 2. We'll print out X. We'll get 2. We'll change Y. We'll get 4. Hopefully you start to see what you start to realize what we're gonna have on the console, right? This is an infinite loop, right? So write that down here. This is an infinite loop because the value X is not being changed by this statement. It's not being changed at all inside this loop. And so this will print 2 repeatedly over and over again. It's probably a programming error, right? It's probably just a slip up. We meant to type X or something like that. It's something that's very easy to have happen to you, but you want to keep your eye out for it, and you got to be able to recognize it when it happens. Over here is a little bit better version. So we've got X is equal to 2. We've got Y is equal to 10. While X is less than 5, we'll print out Y. Okay, so we'll print out 10. We'll increment them both. So we have 3, we have 11, and we'll go back around a loop. All right, so now X is 3, it's still less than 5, so we'll print out Y, 11. We'll change it for 12. We'll go back around. 4 is still less than 5, so we'll print out Y, which is 12. Right? And now we'll increment them again. And we'll go right around a loop. 5 is not less than 5, so we're done. Right? And there's our output. So we don't necessarily need to print out the value that's going around that's being used to control the loop. Sometimes we do, like in this case. Sometimes we don't. Okay, so just to kind of close up this module, probably the most important aspect, and you saw me do it in one of the examples. You saw me do it in the prediction of the output. One of the most common mistakes for when you start to learn loops is an infinite loop. It's a classic programming problem, and the way you can always make sure that this won't happen to you is to always ask yourself, is there something going on inside the loop, inside the code in the loop, that has a chance to make this loop become false? If there isn't, you're always going to have an infinite loop. You will always have this problem. You can be asking the user to type something inside the loop. You can be incrementing a value, you could be decrementing a value, you could be doing anything to those values. But as long as you're becoming closer, if there's some way to actually have that Boolean expression become false, you should be okay. Whenever you see your program hang, just kind of sits there, does nothing, or maybe prints out the same thing over and over again, what you should first go look at is your loop. Your loops are the only things that can cause things to repeat like that. The hanging of a program is because what you're repeating is not printing. All right, so if you're adding 3 to 3 over and over and over again, that doesn't print anything to the screen, so the computer doesn't really tell you that there's a problem necessarily. But you want to learn to recognize that as an infinite loop, and then just hit Control C and go debugging.